This is the homework for 3.8, 3.9, 3.10, 3.12, and 3.13. For problem 3.8, you have a three-dimensional shape that's called a cylinder. Its bottom and top bases are the same size circles, and its side is perpendicular to the base. What would the shape of the flag need to be in order to generate a cylinder when it spins about its pole? So if we have a cylinder, here's our cylinder in purple. In order to have a flag on a pole, its shape needs to be a rectangle. So as this rectangle spins about, you can see that it would create a circle top and a circle base because the radius is the same distance all the way around, so it would create that circle, and the same would be here. So you'd have, and then the side would be created by the length of the side of the rectangle. For problem 3.9, you need to graph each line on the same set of axes. So we have the x-axis and the y-axis, and all three of these functions need to be graphed on these axes. So remember, in function notation form, it's the same as in slope-intercept form, except you have f of x and here you have y, but they both represent the output. The m represents the slope, so this is the rate of change. The b value represents the y-intercept. So this is where it crosses the y-axis. So this function on the y-axis starts at -3, -1, -2, -3, and it has a positive slope. So it'll be sloping or slanting towards the positive x values. And it has a rate of change of 3/1 because 3 divided by 1 is still 3. So rise 3, 1, 2, 3, run +1. Rise 3, run +1. And it has a constant rate of change. It would go on that, it'll go for that rate infinitely. This next function has a negative slope or a negative rate of change, and it has its y-intercept or starts on the y-axis at +3. So +1, +2, +3, there's our y-intercept, and it has a negative slant or a negative slope of 2/3. So I can do +2, -3, or I could do -2 and +3. As long as one is negative and the other one's positive, it doesn't matter. The rise could be -2, +3, or +2, -3, +2, -3. The last function also has a negative rate of change or slope, -4, and its y-intercept is at +5. So we have +5, 1, 2, 3, 4, 5. There's our y-intercept. And it has a negative slope, so it's going to be slanting towards the negative x values. And it's -4, 1, 2, 3, 4, +1. -4, +1. Or +4, -1. And one thing that you can see the difference between these two functions is this has a small rate of change, and this has a larger rate of change or slope. So the smaller the value is, the less steep it's going to be. So here's -2/3. Well, the greater the rate of change, the steeper that line is going to be. Problem 3.10. AC is a straight segment as shown in the diagram. If the distance between points A and C is 67 miles, so A to C is 67 miles, determine the distance between points A and B. So we know A to C equals 67 miles. And we have line segment AB, and line segment BC. And we add those two, we get 67. So we know that line segment AB has a value of 5x minus 2. And line segment BC has a value of 2x plus 6. So if we add the like terms, so here we have 5x and 2x, those are like terms, and then negative 2 and positive 6. So 5x plus 2x equals 7x. Negative 2 plus 6 equals positive 4. And now we solve for x, subtract 4 from both sides, and we end up getting 7x equals 63. Now, inverse property of multiplication is division, so we're going to divide both sides by 7, and we get the big one or giant 1. What you do to one side, you do to the other. And so we get x equals 9. So that gives us x, but we needed to determine the distance between A and B, so line segment AB. So we're going, if we know x equals 9, we can plug it into this expression. So A to B equals 5x minus 2. We're going to plug in 9 into that expression. And now, instead of x, it's going to be 9. 5 times 9 is 45. 45 minus 2 equals 43. So line segment AB equals 43 miles. Problem 312. First, we need to make a scatter plot on graph paper and draw the line of best fit. Then determine the equation of the line of best fit. So here's the data from the table. This is the input, this is the output. The x variables, the y variables. So tired behaviors, so we have 2 on the x, 73 on the y. So 2 on the x, 73 on the y. And I'm going to go ahead and plot all of these points on the graph. And once we plot them all, you have to do a line of best fit. And when you do a line of best fit, you want to have approximately half of the data points below the line of best fit and half of the data points above. So I have 1, 2, 3, 4 below, 1, 2, 3, 4, 5 above. And again, it's just an approximate. And then you want your line of best fit is going to go right in the middle of all of those data points as best as you can. So it's just an approximation. Once you do that, you now want to determine the equation. And the reason why you want the equation is because you can use that equation to determine for any data points that you want. You can find an approximate test score for any number of tired behaviors. So the first thing we're going to do is find the slope. And remember, the slope is delta y over delta x, the difference of the y's over the difference of the x's. And I chose 2 data points that I knew, or just approximate data points on the line of best fit. And I said that the x value for 5 is approximately the y value, 61. So that's one of my data points, 5, 61. And the other data point is here on the y-axis. And I chose this one because this gives me my y-intercept, my initial value. And I'm saying this is approximately 94. And your line of best fit could vary from mine, but it should be around 94. So my data point for this is 94. And now I'm going to use the slope formula, difference of the y's. So I have 61 minus 94 over the difference of the y's, 5 minus 0. And 61 minus 4 is negative 33. 5 minus 0 is 5. So my slope is approximately negative 6.6. So I have my slope now, And to find the equation, I also need the y-intercept. So slope-intercept form, y equals mx plus b. We have the slope, which is negative 6.6, or negative 6 and 6/10. And my y-intercept, where it crosses the y, or intersects with the y-axis, is at 94, positive 94. And I know that this is a negative slope because it's sloping negatively towards the negative x values. If it was sloping this way, it would have a positive slope value. And now I have the equation for the line of best fit. For 313, I need to draw a slope triangle and use it to write the equation of the line shown in the graph. Well, here's the line that's shown on the graph, and here are the two given points, 2, 9 and 4, 16. So for the slope triangle, you have the rise over the run, or the difference of the y's over the difference of the x's. And so what is the difference of the y's? I start at 9 and I'm going up to 16. Well, it's 16 minus 9. Well, 16 minus 9 equals 7. And now the difference of the x's is going to be, I'm going from 2 all the way to 4. Well, 4 minus 2 is 2. So I have a run of 2 and a rise of 7. So my slope is 7/2, or 7 over 2. Now I need to come up with the equation for this in slope-intercept form, y equals mx plus b. I know it's a linear equation because these any 2 points will create a line, and it has a constant rate of change of 7 over 2. So it's a linear equation. That's why I'm using slope-intercept form. So I found the slope, which I know is 7/2. We got that from using the growth triangle. Now I need to find the y-intercept, where it intersects with the y-axis. Well, it looks maybe somewhere around 2.5 or so, but I'm not sure. So I'm going to have to solve for b. In order to solve for b, I need to know x and y. And I can use either of these points, the x and y values here or the x and y values here. Doesn't matter which one I plug in. So I'm going to go ahead and plug in these two values. X is 4 and y is 16. So y is 16 and x is 4. So now that I have these two values, and I could have used 2 for x and 9 for y, and I would have ended up with the same result. Now I'm going to solve for b. And I'm going to do that by simplifying this 7/2 multiplied by 4, and here's 7.5 multiplied by 4, and I wrote it as a ratio, 4 over 1. Didn't change the value, it still has the same value. And you can cross cancel. 2 divided by 2 is 1, 4 divided by 2 is 2. And now I have 7 multiplied by 2, which is 14. Still don't have the value of b, because we're trying to find in slope-intercept form y equals mx plus b. We have the slope, but we don't have the b value. So now inverse property of addition is subtraction, created a 0 pair. 16 minus 14 is 2. So b equals 2. So now that's going to go ahead and give me the missing term that I needed to put it into slope-intercept form. And so remember, the slope was 7/2, and we found the b value, the y-intercept of 2. So y equals 7/2 x plus 2. So before, I thought it was maybe around 2.5, maybe a little less. I didn't know, so that's why I had to find the actual y-intercept, or the b value.